Okay, I got a request to do problem 6 from exam 3, and so let's try to go through this. So it says, what constant acceleration is required to increase the speed of a car from 30 miles an hour to 50 miles an hour in 5 seconds? Okay, and so the first thing that I would say is what what's said in the hint here. So the thing that's going to make this possible is this relationship between location, acceleration, and velocity. Okay, so we know that if you have a function s of t that describes location at time t, then s prime of t is going to be the velocity at time t. And then if you take the derivative of velocity with respect to time, what you're going to get is the acceleration at time t. Okay, so now we kind of want to take the antiderivative to go backwards in this little chain of relationships. So what we want to do is suppose that the car is accelerating at some constant rate. Okay, so the car is accelerating. This is the acceleration function. And I'm just going to say that the acceleration is c. It's some constant. I don't know what the constant is, but the problem tells me that the acceleration is constant. So I can suppose that the function that describes acceleration as a function of time is just some constant c. And I'm going to call it c1 because another constant is going to show up in a second. Okay, so now what do I want to do? I'm given some information about the speed, so in other words the velocity of the car. Alright, so I know what the velocity function is, so maybe I can put these things together and come up with something. Alright, so I take the antiderivative, right, of acceleration to get velocity, and I get this new constant c2. Alright, so now let's just take a step back and realize that the problem here is to find c1. Okay, and we can use this data that we're given to do it. So look, let's just imagine it says the car starts at 30 miles an hour and goes to 50 miles an hour. So what does this mean? Let's suppose that the time starts at 0 when the car is going 30 miles an hour. Okay, so v0 is equal to 30. On the other hand, it should be the same thing as what I get when I plug 0 into this equation, and so that means that 30 is equal to c2. Okay, so this is good. There are two constants I don't know, and I just found one of them. Okay, so c2 is equal to 30. I'll just write that right here. Okay, and now what I want to do is, now that I know one constant, I can use this information to find the second constant. So what you might want to do is write v of 5 equals 50. Okay, but that's actually wrong, and it's a frustrating thing with the units. So notice that the units here is in seconds, but the units here are in hours. Okay, so we're doing everything in terms of hours, and so you can't put in 5. It's kind of dumb. You have to put in what 5 seconds is in terms of hours. So if you think about it, each second is 1/3600th of an hour. So 1/3600th of an hour is equal to 1 second. Okay, so what we want to put into the velocity function actually is 5 over 3600. And where does this come from? You know, it's 60 seconds in a minute and 60 minutes in an hour, and 60 times 60 is 3600. Alright, so I plug this in and I get c1 times this unfortunate number 5 over 3600. Okay, plus c2, but now I know c2 is 30. Now this really is equal to 50. Alright, and look what we have here. We have an equation in which the only unknown is this thing that we want to know, Mr. C1. Okay, so now I just solve for C1. So let me switch back to red. So now C1 is equal to, what should I do here? I need to move 30 over to the other side, so that's going to make this 20. So it's 20 times the reciprocal of this thing, 3600 over 5. And maybe I won't even need a calculator, so what is this? This is just 4 times 3600. Alright, and let me do some multiplication over here. 4 times 36 is 24, and then I get 12, and then it's 14, and then I've got two zeros. So now I know that C1 is 14400. And what is this? This is acceleration, right? So C1 was the rate of acceleration. And so what are the units? It's going to be miles per hour per hour. So miles per hour squared. And this is the answer. So what this means, is that he's accelerating at a constant rate, and that rate is such that every time an hour passes, his velocity increases by 14,400 miles per hour, which sounds like a lot, but when you accelerate in your car, if you just kept accelerating like that, eventually you'd be going pretty fast. And so, great, that's the end of the problem.